back to the SMLC's Python course. In this section we've been learning about Seaborn, and we've learned about different types of plots and style. Today we'll be using this in implementation and seeing exactly how you can make graphs like all of these, and how to change their style as well. So let's get right into it. First, let me go up here and import Seaborn. Like I mentioned at the beginning of the first video, you have to import Seaborn as SNS. I've also added a whole bunch of other libraries from the past, like NumPy and Pandas. Then you also have to use tips pd.readcsv. And finally, you have to use matplotlib.pyplot, which is another variation of a module. You'll understand why this is important in just a bit. Now when it comes to tips, this is going to be a CSV file. If you remember from the Pandas lecture, a CSV file is a file that shows up like this in your Python. And basically what it does is it will give you correlative data that you can then use to manipulate. As you can see, we've used tips with the word tip here for the dist plot. So I'm just gonna implement this code, and once it initializes and connects, yes. So as you can see, there's all these different types of plots, and let's just get right into starting to do it. So first, let's go over one or two distribution plots, the basic ones at least. So let's do sns.distplot. So sns.distplot is quite simple. Remember, it's just sns.distplot, and then you do, I believe it is, let's go back up and check. It's just, you put your series in. So that's my bad. For sns.distplot, we put our series in, which would just be, in this case, tips, and then we can put whatever series we want. Let's put total build for today. Now when we run this code, let's see where exactly total build is distributed. And it's distributed, as you can see, near the number 20. As you can see, distplots are good for distribution and seeing where exactly your data is. Now let's look at the next section of our Seaborn, and that has to do with using x and y. Now, we've already used distplot, but let's just see another example so that we can see how to use two variables with the scatterplot. And for sns.scatterplot, we'll do this, and then data equals, we'll say tips, x equals tip, y equals total bill. And if you're wondering where I'm getting these column names from, I'll show you in just a minute. We're getting column names from the data tips. So if I show you tips.head, which if you remember from the previous section of this course shows you the top 5 rows. Oh, this seems to be taking a minute. We'll just give this a minute to run. Meanwhile, let's look back at some of these plots. So as you can see, we've already had the distribution plot, and now the scatter plot again. Keep in mind that you're using two variables to plot. I think we'll just stop that. I'll just show you tips at it like right now. Maybe this will work. Yeah, as you can see all these columns of tips. There's total bill, tip, sex, smoker, day, time, and size. And that's exactly what we're using for our code. Now let's go on to the next section, which will be the joint plot. Actually, we'll go to the pair plot, which is almost like a grid. The pair plot I think is quite interesting because I think it shows you all different types of plots, and it's pretty cool. So we can do sns.pairplot, and keep in mind the only parameter here is our data, so we can just put tips. Now when we run this code, it'll just take a minute because it's quite big. Yes, okay. As you can see, it uses 3 different variables. In this case, size, total bill, and tip. It only uses these 3 because these are the only 3 numbers. If you remember from our, just open a new code cell again. If you remember from our tips data frame, there's only 3 columns with actual numbers. That's size, total, tip, bill, and tip. So PairGrid has made it quite nifty for us and automatically figures out which sides and which parameters and columns have grids. Now that you understand the basics of distribution plots, let's move on to the matrix plot. Tips, especially, or let's move on to the categorical plots. We'll get back to the matrix plot in a bit. First, let's go over the basics of the categorical plots. Of course, there are many, but there are specifically 5, but I'll go over 2 of them today. Let's do just sns.countPlot. So SNS.countPlot, if you remember, is x equals, we'll use size for now. How about that? X equals size, and data equals tips. Now what should happen is, as you can see, it counts how many of each size there are. If you remember from our data frame, there are sizes. Like, there's only 1, 2, 3, 4, 5, and 6. So our implementation here has shown us that the majority of them is size 2. This can be really good for some rudimentary data cleanup as well, if you just want to see how many there are. Obviously there are simpler ways to do it, but it's rather fun to figure out exactly on a graph. Now the second type of plot we'll be looking at is a strip plot. I'll use a strip plot because it's similar to a box plot and violin plot, and it also encompasses all the concepts you need to know about it. A strip plot is also quite similar again. Let's look at it one more time. It's SNS.stripplot. X equals, we'll do total bill. Actually, you know what, we'll do size. Let's do size. X equals size. Y equals total bill. And then data equals tip. Tips. There. Now what you see is, of course, the distribution of values across certain sizes, and you can see that total bill is more dense in size 2 at around 15 to 16. And there's not really many size 1, so we can't make any determinations. And the same thing happens with size 3 and 4, where they're still a little bit more denser on the size 20. Now let's look at the heat map. Now to make a heat map, keep in mind you have to make a correlative table. So how that looks is what you have to do is you first go tips.core. Now when I run this, you'll see, oh wait, actually I'll just stop that. Let's go tips. I'll just show you exactly what tips look like right now. Seems to be taking a while. Okay. Meanwhile, while that's happening, let's just do tips.core. Interesting. So these seem to be taking a while to run, but what I'll do is I'll basically just wait for this to run. Okay, perfect. Now it's working. So let me show you what would have happened beforehand. Let me show you exactly what tips looks like right now. This is what tips looks like, where the columns are actually numbers, or the rows are rather numbers, and you can see that there are 244 rows. Now let's look at what happens when I do tips.core. Well, tips.core actually finds ratios between all these different values. Take for example row 0. Well, row 0 has the tips.core index of 1, 0.67, and 0.598315. That's because you can look at the ratio of 2 to 1.01 or 2 to 16.99. So tips.core is really good for that. And then for the heat map, let's remind ourselves how to do it. Let's remember that we go into our code, sns.heatmap, and then all we have to do here is basically just put tips.core. As you can see the density of this. This is quite a rudimentary data set, so you won't really see much. But let's look at an example. As in the middle here, you can see that's around 1, and that's because total bill is always equal to total bill, so the ratio will always be 1. And then maybe we can look at tip, where we see that a tip is only around 0.7% or 0.7 when it comes to a ratio of the total bill. These two columns right here. And yeah, it's quite simple, but it's also quite useful when you have bigger numbers and data sets, as you can see in the previous lectures. Now let's look at a little bit of style and grids. We'll quickly go over one grid, which is sns.pairgrid. Now, sns.pairgrid, it's quite simple. We just go sns.pairgrid, and then we'll just do tips. This will create the grid. Now we go into the next cell. Or actually, let's just assign this to a variable, sns.pairgroups. Okay, perfect. Then we'll go to x.map. Now we can put whatever type of function we want. Let's just do an sns.scatterplot. that seems to be... Okay, one sec. Okay, here we go. That's perfect. So as you can see, now we can see this scatter plot. Again, look at the diagonals. The only reason that they're, of course, solid lines is because x equals y, and if you look at that function, it'll always be a solid line. But for tip, total bill, tip and size, total bill and size, they're all different. And of course, size can only be 2, 3, or 4, so that's why these are in lines. But pretty nifty use of a pair grid as well. It's similar to the, I believe it is the pair plot that we used beforehand. The pair plot is actually a lot easier to use in my opinion, but it's up to you. Now let's go into a quick look at style. Let's do sns.setStyle, which is what we discussed in the video. We'll do white for now. Now what we'll do is let's just try using a random grid that we've used here before. How about count plot? We'll do count plot. So count plot, let's see what happens. So obviously it's currently white right now, so yeah. There's other examples of size as well. Let's use different types of style. Let's use the ticks entry as well. sns.ticks. Okay. And you can also do sometimes other styles as well. There's dark grid. A dark grid will, obviously self-explanatory, will make your grid dark, as you can see here. And you can in fact do dark, general, just dark. That'll make it just dark. And yeah, there's many different ways to use it. There's also the dspline function that we've shown beforehand, and there's a lot more. But these are the basics. This is all you really need to know. And then there's also the sns.setContext, but that it's also quite self-explanatory. We can just do sns.set context, and then we can change it to whatever we see necessary. So let's look at some examples. Just a second. Okay, so for examples for some context, you can use like font scale, RC. These are all different ideas. So let's just look at sns.setContext. We'll do notebook and font underscore scale equals 1.25. Let's make the font a little bit bigger, and we'll see exactly how that looks in just a second. So let's do that here. Okay, you see the size has become a little bit bigger for font. And what that does is it basically creates, well, yeah, you can use this for many, many things. And then now you can use this for line plots, for any other type of plot that you want to use in Seaborn. Now the final thing we'll be going over today is regression plots. So regression plots are quite simple. They basically show you the regression line. So let's use an example of that. The only regression plot in this case, we have lm plot. And that for that it's quite simple. X equals, we'll do tip, y equals total bill, data equals tips. What this does is it shows us a variation, but it also shows us in the middle right here the regression line and exactly a trend line. So this can be really useful for us in the future. So that's about all for this section of the machine learning course. I hope you enjoyed the Seaborn section. Again, if you have any questions, you can refer to this notebook that will be you can refer to this notebook, or you can reach out to the SMLC Coalition. And you can also check the internet for things that I've mentioned before, say things like set context or set style or hue in the majority of most of these grids. The internet will be your best friend, especially when it comes to styling these grids. So don't be afraid to check it out and try new things. Thank you very much.